What is a hexadecimal number and how to convert them? If you haven't seen our video on binary numbers, then I suggest you watch that first to understand number systems, but I'll give a quick recap here. Number systems are a way to express or represent numbers, and there are lots of different types of number systems, but most of us use the decimal number system. Decimal, the first part there is dec, which means 10. With the decimal or 10 number system, we use 10 different digits to represent the number. These digits range from 0 to 9. The moment we go above 9, we use a new column, the tens column, and reset the numbers back to their lowest possible digit, and so on when we get to hundreds and thousands, and larger numbers. In our video on binary numbers, we use the 2 number system where there are only 2 different digits, a 0 or 1. Notice with any number system, the number of possible digits goes from 0 until 1 before the number system's number. When we have used up the digits, then we move to the next column to get new numbers and so on. Now hexadecimal is another number system that is often used in computers. Hex, which is often used to mean the number 6, and dec is often used to represent the number 10. So this is technically the 16 number system. So all possible digits, can you remember the rule? Range from 0 until the 1 before the number system. So the digits used in this number system range from 0 to 15. But that can be a problem because when you look at, for example, the number 13, is that a single digit 13? Or is that a 1 in the next column and a 3 in the units column? So we have to find a way to represent the 10 to 15 as single digits. And so we use letters where A represents a 10, B represents an 11, C represents a 12, D represents a 13, E represents the 14, and F represents the 15 digit. So if we compare the number systems, 0 to 9 are exactly the same in both the decimal and hexadecimal systems. But when we get to 10, the decimal system has run out of digits, so it has to go to a new column, resetting the first column back to 0. But with hexadecimal, we continue with the single digit A. And this keeps going until we reach the number 15. But now we want to go to the decimal number 16, and we have run out of digits in the hexadecimal system. So we have to move to a new column with a 1 and reset the units column back to a 0. So a 10 in hexadecimal is the same as a 16 in the decimal system. And as we go, we increase the units column using up all the digits in the hexadecimal library. So 1A in hexadecimal is actually 26 in decimal. And remember, just like we learned in the binary number video, in mathematics we indicate the number system as a subscript of the number. Because we use decimal numbers by default, we tend to leave that out. But if you are using the hexadecimal system, then you should indicate the subscript 16 so that we know that this 19 is actually a hexadecimal number and not a 19 in decimal. So let's talk about how we can convert numbers between hexadecimal and decimal systems. If we understand the system we use for converting binary numbers, then this should be easy as we are going to follow the exact same procedure. We are going to start with taking hexadecimal numbers and converting them to decimal numbers. But let's just recap decimal numbers. If you remember how they work, taking the number 35,782. At primary school, you may have been taught to divide this number into its units, tens, hundreds, thousands, and tens of thousands, and so on. Here we have 2 units, 8 tens, 7 hundreds, 5 thousands, and 3 tens of thousands. To get this number, we multiply each value with its column and then add all of these together. So we take the 2 times the units, then we take 8 times the tens, and then 7 times the hundreds, and so on. Then we add these products together to get 35,782. But this is the 10 number system. And in this column, each number can be written as 10 to the power of something. So the tens column is actually 10 to the power of 1. The hundreds column is actually 10 to the power of 2. The thousands column is actually 10 to the power of 3, and so on. Each column is 10 to the power of the next counting number. If we continue with this pattern backwards, then the units is technically 10 to the power of 0, which in mathematics is 1, so it still works out. So let's think about a decimal number as each column is basically the number system, in this case a 10, to the power of counting numbers going up, remembering that the first one always starts at 0. Then we multiply each digit with its own column value, and then we add up these values to get the decimal number. Now let's apply the same logic to a hexadecimal number, like 1A3F. Each column is represented by the number system, a 16 in this case, to the power of an increasing counting number. But what must we always start at? A 0 first, then a 1, then a 2, and then a 3, and so on. So 16 to the power of 0 is 1, so this represents the ones. The second column is 16 to the power of 1, which represents the 16s. The third column is 16 to the power of 2, which represents the 256s. And the fourth column is 16 to the power of 3, which represents the 4096s. And so this would continue if we had more digits in our hexadecimal number. 16 to the power of 4 or 16 to the power of 5 and so on. Now there is an extra step we must take before we start multiplying out the values. And that is to change any letters to their numerical value. So we are looking for any A, B, C, D, E's or F's. So this A we must convert to a 10 and this F must be converted to a 15. Now that that part is done, we can apply the same strategy as we did with the decimal numbers. We take each digit multiplied to the column value. So F, I mean 15 times 1, and then 3 times about 16, and then A, I mean 10 times about 256, and then 1 times about 4096. And then we add these numbers together. So if we sum these products, we end up with a number of 6,719. So we see that 1A3F in hexadecimal is the same as 6,719 in decimal. So let's take another example with E7D. Each column is 16 to the power, and the first column is 16 to the power of 0, then 1, and then 2. Then we convert any letters to their numerical values. So the E becomes a 14 and the D becomes a 13. Then we multiply each column to the digit value. So 13 times about 1, 7 times about 16, and 14 times about 256. These products are 13, 112, and 3,584. And now add those values together and we get the decimal number of 3,709. And that's how you convert a hexadecimal number to decimal. But what about a decimal number to hexadecimal? Now we are going to use that special mathematical technique named after me, the Mr. Long division. Actually, it was developed by a mathematician called Henry Briggs in the 1600s, but I'm not really sure why he named it after me, but anyway. So let's take 6,719 because we know what the answer to that one is already. We take the number to be converted and we are going to continuously divide the number by the number system we want. In this case, a 16, because we want to convert it to a hexadecimal number. And we are going to continuously do this until we have nothing. Nothing meaning 0 left to divide. Remember, it must be nothing. And we need to take note of the remainders each time we divide. You remember remainders? For example, if we divide 15 by 6, that means 6 can go into 15 twice. And then we will have 3 left over. That 3 is the remainder. Remainders are not the numbers after the comma when you use a calculator, like the 0.5 in this example. It's what is actually left over. In this case, 3 is left over. So let's start. 6,719 divided by 16 is going to equal to 419 point something. We don't worry about the decimal value. We just take that whole number and place it there. Now, in order to find the remainder, we're going to take that whole number, 419, and multiply it by 16, which is the number system that we're trying to find the remainder of. And the answer to this is going to be 6,704. Now, the remainder will be the difference between the 6,719 and this new number, 6,704. In this case, the answer is 15. Just a reminder that your remainder will always be smaller than the number that you are dividing by, so it'll never be larger than 16 in this case. Then we continue dividing by 16, so we take that 419 divided by 16, and we get an answer of 26 point something. Again, we ignore the decimal numbers, and we want to work out the remainder, which is going to be 26 times by 16, which is going to be 416. The difference between 419 and 416 is 3. So that is the remainder. So we are left with an answer of 26 with a remainder of 3. We then take the 26 and divide it by 16. We get an answer of 1 point something. Again, we don't care about the decimal number in this case. But this one's quite easy because 1 times 16 is 16. And the difference between 26 and 16 is 10. So we are left with 1 remainder 10. Now remember, we must keep going until there is nothing or 0 left to divide. We have 1, but that's not 0. So we must keep going until 0. So 1 divided by 16, quite easy. It is 0, and the 1 is all that's left over as our remainder. And now that we are at 0, we can now stop. Now I want you to look at all those remainders, but I want you to look at them from the bottom up. take that 1, 10, 3, and 15. But we first want to convert the 2-digit numbers into their letter equivalent. So the 10 changes to the letter A, and that 15 changes to the letter F. And now we go from the bottom up, and there we have our answer that 3,719 is equal to 1A 3F in hexadecimal. So we take a number, divide it continuously by the number system we want to convert to it, in this case a 16, and we keep track of all the remainders, the leftover values, and then we arrange them from the bottom up. Started from the bottom, now we're here. So if we take the number 1,803 and divide it by 16, we get 112 point something. We again ignore the decimal values, and 112 times 16 is 1,792. The difference between these two numbers is 11. So we're left with 112 remainder 11. Then 112 divided by 16 is equal to 7 exactly. And 7 times by 16 equals to 112. So in this case, there is no difference. So the answer is 7, remainder 0. Now remember, we keep going until we reach 0 or nothing to divide. Now we take that 7 and divide it by 16, and we're left with 0, remainder 7. Remember, we keep going until we get 0 or nothing left to divide. Now we are done dividing, and we convert any 2-digit numbers into their single letters. There, that 11 needs to be converted into a letter B, and then we look at these remainders from the bottom up. That's 70B. And we can now see that 1,803 is equal to 70B in hexadecimal. Just note that some hexadecimals don't have letters in them, like the number 291 in decimal is actually 123 in hexadecimal. And there you have it. You can now convert hexadecimal numbers to decimal and decimal numbers to hexadecimal. By the way, when you have decimal numbers below the units, we usually use 10 to the power of -1 and 10 to the power of -2 and so on. We just follow the natural number sequence. We can do the same with hexadecimal numbers that are fractions. We know about 16 to the power of 0 and 16 to the power of 1 onwards. But to do the fractions, we will just follow the natural sequence of numbers. So we just go 16 to the power of -1 and 16 to the power of -2. And if you remember your math, 16 to the power of -1 is just 1 over 16. And you can use your calculator if you want to work out the other values. And now you just apply the same mathematical method to calculate the fraction part. So there you have it. Now try to convert these hexadecimal numbers to decimal, and try to convert these decimal numbers to hexadecimal. If you want the answer, you can use an online hexadecimal calculator, or you can use your computer's calculator app. Search for it, or you can press the Windows R key together, and then type in CALC, and you should be able to find the app. When the calculator is open, click on the top left-hand corner there, and there you should see an option called Programmer Mode. If you select it, you can now see that it's set to decimal. So if you type in 109, you'll notice that the answer for the hexadecimal can be seen in the hexadecimal part or the hex part, which in this case is 6D. And if you click on the hex option, you are now in hexadecimal mode. You will now notice that you have access to all the digits from 0 to 9, as well as the letters from A to F, so that you can input hexadecimal numbers. So if you type in AB9, you'll notice that next to the dec or decimal part, you can see that the answer is 2,745, meaning AB9 in hexadecimal is 2,745 in decimal. Now that you know how hexadecimal numbers work, go and work out your phone number in hexadecimal. The next time someone asks for it, give them that version, and if they're sharp enough to work it out, then maybe they are deserving of being your friend. Remember, if you don't want to miss out on a computer term, make sure that you click on that subscribe button for @Mr. Long Computer Terms, as well as our other channel @Mr. Long IT and Cat. We're also on TikTok @Mr. Long Education. And remember, don't do it the long way, do it the Mr. Long way.